Hi, in this video, I am going to talk about something so obvious and easy, but critical. Large object heap. Something that we should try to be prevented from. Why? To handle efficient memory allocation in dotnet, in C#. Okay, let's go and see what I am going to talk about. Efficient memory allocation in .NET, and in this subject, avoiding LOH with segmented arrays and strings. What's the problem? Before talking about the problem, we need to know what is LOH. Let's have a look. What is LOH? The LOH is a spatial memory area. That's all. No need to read the rest. If your array was larger than this size, you will touch that part. Your object should be stored in that place. And then everything is not as usual. Things would be a little bit spatial. Things are not optimized. I'm just talking in a very simple way. What goes to LOH? Something like this, big size, integer in this size or bigger, strings like this. This thing goes to LOH. Okay. In .NET, as we already said, if the size was bigger than this in bytes, you're gonna deal with large object heap. And then your performance would be less. You're gonna deal with performance issues. These two scenarios are the most common scenarios: large arrays or inefficient string handling. If we want to talk about these things on the paper, it would be a very long story. The best way to show you how bad would it be is having a simple benchmark. Benchmark where? In Visual Studio. So let's jump to Visual Studio and see what is happening. This is my source code. The size, total items, which is big, to list, integer, flat list, segmented list. If the source size or font size in the source code is small, let me come back to PowerPoint and talk about the difference between these two. Let's go. The only difference is this. We only try to use our brain to break that big list to small chunks like this. That's all. So by this way, we are not going to go to that LOH to handle things by that LOH technique or area or something like that. So if I come back to Visual Studio, the rest is some loops and easy things. Let's go. See? In flat list, I just happily loop through the data and add it to the flat list. That's all. In the other one, I just used my brain a little bit, converted that data to small chunks, and then I added them to segmented list. So I would have a lot of arrays of integer. That's all. Then if I want to loop through the data in the flat one, it should be like this. In the segmented one, I would have an array inside that segmented list, as you can see here. Then, since the size of everything is smaller than ominous size, I won't go to that LOH area. So if I run and get the result, we will see something like this. See? This is the result of benchmark. If it is confusing or you are lazy to focus and see what is the difference or what happened, come here. Verdict: segmented allocation wins. Why? Because we already explained. The size of arrays are always smaller than this, and it is kind of 40% faster. This is the point. So we only used brain. There is no NuGet package. There is no spatial type of things. No need to be the latest version of .NET or C#. If you be updated, it would be better. But see, we only used brain to be close to 36% faster. What about the strings? Let's have a look. This is another benchmark. You will see a string builder, a string entering, and using a span. If you use a span, things would be much different. For this one, I'm not going to run and I am not going to show you the result. I will share the source code in the description of the video. Run it. If you have better ideas, let me know in the comments. So I will share this small piece of code, or let's say this solution, in the GitHub. Try to use it and let me know the results. As I have always said, use your brain. That's all. As a software developer, you would be much happier. Thank you so much. Hope to see you in the next videos. Bye.